Hello, students. Welcome to the MCs, the Math Connections, section 8.2. Let's see, what do you have here? 2, 5, 7, 10, and 12. Wow, only 5 questions here. Somebody must like you a lot. So let's see here. If you look at that, the 2, 5, 7, solve the equation this using a balance scale. Okay, so again, that one is drawing a picture. So I do want to see that you can draw a picture to solve this equation. And if you're, again, looking for it, the balance scale looks a little something like this. And so on one side, you'd have 3 x's, and the other side plus 5 units, and the other side you have 5 x's and minus 3. So if you're kind of saying, well, how would I demonstrate a minus 3? How can I have a physical object that's worth minus 3? Just build a shape and think about how we've done negatives and positives in the past. We did them with colored tiles. So if you need to, and you want to kind of build up a little bit larger one here. So there's my base. And over here, here's my other one. These are supposed to be equal. When you're looking at x's, you could say, I don't know what an x is. So again, when you're dealing with elementary school students, think of it like a little box. It's a box. I don't know what's in it. There's 3 on that side, and there's, 5 on this side. So build your boxes. Okay. Now the left-hand side has a plus 5. Now remember, when we were doing this, a black chip was positive, red was negative. So I'll put 1, 2, 3, 4, 5 positive chips on the left-hand side. On the right-hand side, all I have to do is put 3 negative chips. And yeah, it goes back to the idea of 0 pairs, but why not use what you know about 0 pairs? So if you wanted to, what could you do to both sides to make this easier, right? It'd be nice if all the little chips were on one side. It'd be nice if all the boxes were on the other side. Think about how you would do that. Again, you're going to be explaining this as if you're explaining it to students. Okay. 2, 5, find all solutions to x squared divided by x equals 0. Okay, so your goal is to find all of those. Typically, again, students might want to simplify first, so simplify, and then make sure when you're done, you go back and check your work. Okay, so that's 2, 5, 7, 10, and 12. 7, we're into the CMCs, math classroom questions. A student claims the equation 3x equals 5x has no solution because 3 does not equal 5. Love it. They're using the cancellation property. I see an X on both sides, so get rid of it. But then you're left with 3 equals 5. That seems a little strange. Why does that seem strange? What is the issue here? Is it possible that could have happened? And think back to those, what they called cancellation properties, what you might call properties of equality. When could they work? Was it true that it was always the case that this would happen? Okay. 7, 10. On a test, a student asked this question, 4x plus 5 equals 3x plus 15. He proceeded as follows. So he wrote this out, which equals this, which equals this, which equals 40. Okay, he checked. 40 satisfies the original. He did not get full credit for the question, wants to know why. How do you respond? What is incorrect about what the student did? Okay, what are the issues with doing it the way that the student has done it? And how would you suggest the student changes it to make it so that they can demonstrate they have the right idea and the notation is correct? Okay, a student claimed the equation 2x equals 3y has infinitely many solutions and said she could prove it using ideas from number theory. What type of argument might she have made? Interesting. Number theory, which was chapter 4. Those are multiples. So is there something that you could do with multiples to show that 2 times some number equals 3 times another number will have infinitely many solutions that are whole numbers, not fractions, anything like that. Infinitely many that are whole numbers. Think back. Again, I'll put that up here for you. This is chapter 4 material. If you need to flip back, it is in your textbook, so use that as your guide. That does it. All right, that's all I've got for you for now. Off you go.